Okay. Assalamualaikum and greetings to all of you. So I welcome all of you to our virtual session in this InECCE 2025. So I extend my gratitude to all of you around the globe for your interest in joining our session. I would like to give some uh, rules about for each participants. You all are allowed for a duration of 10 minutes in total, preferable 8 minutes for presentation and 2 minutes for Q&A session. So before we start our session, I would like to confirm the status for our presenter, paper ID 50, Dr. Agahya. Dr. Agahya, are you here in this meeting right now? Mm, mm, okay. I confirm I think the first presenter is not yet here. So maybe we can proceed with the next presenter. Um, Mr. Ibrahim Alafi for paper ID 189. Five flash on article. Hmm, no, I guess no response. So I will proceed with paper ID 97. Overview of grounding system improvement. I want to confirm your status in this meeting, please, by Mr. Banjo Abu Bakar. Still no response. Aku tengok list ada. Wait, ni Banjo Abu Bakar. Ya, siapa? Tak ada lah. Tak ada. Ni ada. Ini. Dia. Oh, okay. Aku rasa dengar kan? Dengar. Hmm. Jom. Semua yang dah lama ni. Oh, tak ada clue. Dia keluar tu. No respon tu. Um, Kejap tengok. Albert Antonio Bebaidi Desi. 55 American Count. Siapa jadi? Cuba cuba kau tengok dia. Dalam tengok list ni dekat ni. Siapa jadi? Dia orang Rahim Alafi aku dah panggil tak ada. Jauh ke pagi ni masuk. Oh tak ada dia keluar. Uh, uh, siapa next? Siapa next? Syeda Fariha. Syeda Fariha. Tak ada juga. Sebab dia orang ikut timing ni. I guess okay, siapa baru masuk ni? Uh, Anyone can anyone respond to me? Did you hear my voice?
Yes, yes, I hear your voice. Yeah, it's perfect voice.
Okay, thank you so much. Um, Maybe since maybe okay, Mr. Dui.
Yes,
Since
yes, I'm
the
here.
Based
Yeah,
on my list,
my
can you
paper
can you
is
can you make a first presentation first,
yeah,
if
of
you're
course.
able to? Okay,
Yeah.
so because you are here, then I will play your video first. All right?
Okay. So my
Okay.
paper 146 and 147.
146 and 147. Okay, okay, okay. I will play
Uh,
146
yeah.
and 147.
Okay.
All
Great.
right.
Thanks.
Thank you so much.
Okay.
146 and 147. So I will start with paper ID 146 first. All right.
Okay.
Okay.
Hello everyone. My name is Yui. Today I would like to present the topic optimization of hybrid DC and AC microgrid configuration using chaos artificial P colony algorithm. The increasing demand for reliable and resilient power supply, seamless renewable energy integration, cost reductions, and electrification of remote areas has led to the growing adoption of hybrid DC and AC microgrid. However, optimizing the microgrid configuration remains a critical challenge due to the uncertainties in renewable energy sources and varying load conditions. This paper proposes an optimization approach for determining the optimal configuration of a hybrid DC and AC microgrid, including the optimal number of solar PV panels, the optimal wind turbine, and the total optimal battery capacity. This optimization problem based on the objective of minimizing the cost energies. So in order to solve this problem, we propose a chaotic artificial peak calling algorithm leveraging chaotic maps to enhance global search capability and convergence speed. The objective functions of these problems is described by the cost of energies. The configuration optimization of a hybrid DC and AC microgrid is observed by um, constraints of the renewable energy source. The constraints of um, the power patterns of the microgrid, the constraints of battery storage. In order to solve this minimization problem of the cost of energy, we propose chaos, chaos ABC algorithm to solve this problem. We talk a little bit about this algorithm. The APC algorithm introduced by Caraboga in 2005 draws inspiration from foraging habit of bees. It operates on the remains of three artificial bees within a colony, employ bees, unlocker bees, and scout bees. By using this algorithm, we obtain the solution of the optimization problem, and achieving an optimal solution requires effective exploitation during the search process. And chaotic map has been recognized for the ability to generate diverse solution space and enhance the exploitation capability of the ABC algorithm. In this proposal, we are using the chaotic sequence based on the logistic map. In order to approve for this proposal, we consider a hybrid DC and AC microgrid consisting of solar PV panel, wind turbine, battery, and DC and AC load. we apply the chaos ABC algorithm to determine the optimal number of the solar PV panel, the optimal number of wind turbine, and the total optimal battery capacity. Um, this is the specification of solar PV panel, wind turbine, and battery. In addition, we also have only average solar irradiation, wind speed, and loss. Um, Finally, we have the optimal configuration of the hybrid DC and AC microgrid by using the chaos APC algorithm with the optimal of the number of solar PV panel and the optimal number of wind turbine and the total optimal battery capacity and also the cost of energy. Um, in order to confirm the effectiveness of um, the chaos ABC algorithm, we also apply ABC algorithm, PSO, and GA algorithm for this optimization problem, and we obtain the optimal configuration of the hybrid DC and AC microgrid, and we can realize the result of the chaos ABC algorithm is better than the result of using ABC, GA, and PSO algorithm. So, moreover, we also have the comparisons of the performance of the chaos ABC algorithm, and PSO and GA algorithm. And we also realize the performance of the chaos ABC algorithm is better than the performance of ABC, PSO, and GA algorithm. So finally, we have the conclusion. This paper proposed an optimization approach for configuring a hybrid DC and AC microgrid by employing the chaos APC algorithm. The optimization aim to determine the optimal number of solar PV panel, wind turbine, and total battery capacity while minimizing the cost of energies. The chaos APC algorithm was introduced as an enhancement of the standard APC algorithm by incorporating chaos map to improve solution diversity and conversion speed. The effectiveness uh, of the proposal methods was validated through a numerical solution and a comparison with ABC, GA, and PSO algorithm. So this is my presentation. So thank you very much for your listening.
Okay, thank you so much for the video presentation. So I would like to open a Q&A session for 2 minutes. Is there any participant want to ask some question regarding about this paper? Okay, okay, yes. Yes, Mister, you may ask question to the presenter. Hello, did you hear me? Hello. Okay, so I guess then I will ask a question. So for this research, um, is it possible to use another optimization algorithm aside from swarm based algorithm?
Yeah, thank you very much for your questions. So basically, you can consider the
Hello
algorithm.
everyone. My
Sorry.
name is Duy. Today I would like to present the topic So
optimal
can you stop
upgrade of an
the
island
presentation?
solar
Okay.
photovoltaic microgrid using
Okay, so I will like to okay, thank you for the answer. So I will move to your next paper, paper idea 147.
Yeah,
Hello
okay. Thank you.
everyone. My name is Duy. Today I would like to present the topic optimal upgrade of an island solar photovoltaic microgrid using a gray dwarf optimization algorithm. So, the increasing demand for reliable and sustainable energies has led to a growing interest in microgrids, particularly uh, Iceland microgrid powered by renewable energy sources. Given a contrast that additional solar PV panel cannot be installed, the research focused on expanding the battery storage system and integrating diesel generators as backup power source. This paper proposed an optimal upgrade approach for an island solar PV microgrid to accommodate increasing load demand by using a gray dwarf optimization uh, algorithm to determine the optimal number of battery and the required diesel generator capacity. So we consider an island solar PV microgrid, including solar PV panel, battery, and AC load. The objective functions of the optimal upgrade problems is based on the total cost, including the cost of the battery, the cost of the diesel generator, and the cost of the consumed fuel of diesel generator. Um, the constraints of the optimal upgrade of the island solar PV microgrid, including the constraints of the power balance, the constraints of the battery state of charge, the constraints of charge and discharge of the battery, the constraints of the output power of the diesel generator, the constraints of the energy sufficiencies of the microgrid. So, in order to solve this problem, we propose um, the gray graph optimization algorithm to optimize the objective function. So we talk a little bit about this algorithm. It is a nature-inspired meta-heuristic based on the social hierarchy and hunting behavior of gray wolf. This model follows leader, advisor, scout, and follower. The hunting process involves three main steps: ensnaring prey, hunting, and attacking prey. In ensnaring prey, we have the solution, and we have update the solution by hunting. And finally, we have the transition from the search to conversion by exploitation and exploitations. So in order to approve for the proposal, so we consider the solar PV microgrid, including solar PV panel, battery, and AC load. Um, this is the current configuration with a specification of solar PV panel and a specification of battery. During operation, the loss increase, and we need to upgrade the microgrid with the optimal configuration of the microgrid corresponding to increasing load demand by using GWO algorithm. So we got the result, the number of the PV panel is constant. The optimal number of the battery and the optimal number of diesel generator. So in order to confirm the effectiveness of this application, we also have the comparison of optimal upgrade result using the GA and PSO. We can realize the result by using GWO is better than the result by using the GA and PSO algorithm. So furthermore, we also have the comparisons of performance of the GA, PSO, and GWO algorithm. And we also realize the performance of the GWO algorithm is better than the performance of the GA and PSO algorithm in terms of convergence value and iteration number. So finally, we have the conclusion. The paper proposed an optimal upgrade approach for an island solar PV microgrid to address increasing load demand while minimizing total system costs. The GWO algorithm is employed to determine the optimal number of battery, the required diesel generator capacity, ensuring system reliability and cost efficiency. The results demonstrate that the GWO algorithm outperform traditional optimization techniques such as the GA and PSO algorithm in terms of solution quality and convergence performance. So this is my presentation. Thank you very much for your listening.
Okay, so thank you, Paper ID 147 for the video presentation. So I would like to open a Q&A session for, is there any participant that want to ask question, please? You may open your mic. So I guess there's no one to ask. So I would like to ask about this paper. So in your future work, would you planning to perform another algorithm optimization or do an improvement to the GWO? That's my question.
Yeah, thank you very much for your questions. So basically, this is the original GWO algorithm. So probably in the future, we will develop this algorithm so that we can improve the performance of this algorithm. And we also probably we also consider for another configuration of the microgrid. For example, we can consider more component in this microgrid. So there's so many future direction for develop this topic. Yeah.
Okay, thank you for the answer. So I think I would like to start from the first list. So I guess the next presenter will be Dr. Ahgaria Subia. So I want to confirm your status in this meeting again. Are you here? Dr. Ahgaria is still not here. Okay. Okay. So due to time constraint, I would like to move to the next list, which is paper ID 189. Are you presenter? Are you here, Mr. Ibrahim Alafi? Can you respond? Again, can you hear me? Okay. I will proceed to next. So next paper in list is paper ID 7, Mr. Banjo Abu Bakar.
Yes, Amir. Good morning.
Okay, good morning to you as well. So I will proceed with your video presentation, okay?
Thank you very much.
Thank you.
Good day, everyone. My name is Banjo Abubakar, and I'm presenting the paper Advancement in Grounding System Design and Materials. This is a review paper on design, simulation, and enhancement materials used in grounding systems. I'm from University Malaysia Police. Basically, there are two major types of grounding, which is equipment grounding and earthing. Equipment grounding connects not current carrying parts to safe path, while earthing ensures such energy, basically lightning, to be dissipated into the soil. But the two types of grounding are used for securing of human and equipment. For equipment grounding, we have ground wire, we have grounding conductor, and we have breaker panels. And for earth grounding, it basically consists of ground rod, earth electrode, and soil interface. But generally, the earth grounding comprises of the air terminals, the down conductor, before the grounding system itself. Broadly, challenges faced in grounding system is high resistivity soil and limited space. Also, the goals is to enhance the efficiency of the grounding system to reduce resistance and also improve sustainability of the grounding systems. From grounding system, the Malaysian standard is residential building. We have less than or equals to 10 homes. For commercial premises, we have less than or equals to 5 homes. For industrial facilities, we have less than or equals to 1 home. And for substations, high voltage, we have less than or equals to 1 home. Then for sensitive equipment like data centers, we have less than or equals to one home. Moving on quickly, when it comes to grounding, broadly, there are two major metals used. We have copper and steel. Also, we have UFO grounding, which is an embedded copper or embedded steel inside concrete, which is basically the foundation of the building is being used, which is entirely dependent on the moisture of the environment. When it comes to grounding materials, there are two broad categories of grounding materials. There are natural grounding enhancement materials and chemical grounding enhancement materials. For natural grounding enhancement materials, bentonite is being used majorly and is being used as a standard. It has high moisture retention and high ion exchange. Then we have wood ash, we have pofar, we have kernel from straw rice, we have zeolite powder, we have peat moss, and we have baucha. All these materials have their benefits and disadvantages. Some of the challenges faced by with wood ash is the fact that there are different types of wood, so you cannot have a standard for wood ash. And the likes of peat moss, it is susceptible to microbial degradation, meaning after a while to lose the resistance, to lose the resistant reduction property. Then moving on to chemical enhancement materials, we have materials like sodium chloride, copper 2 sulfate, hydrogel, we have conductive nanoparticles and waste activated carbon. Just like in the natural enhancement materials, these chemical enhancement materials too, they have their merit and demerit. Majorly, generally, we know that soil and salts will leach into the soil and with corrode metal. Those are the general disadvantages for salt when used as a earth enhancement material. Then when it comes to some materials like hydrogel, sometimes long-term durability might be of concern to us. Then conductive nanoparticles, cost and scalability concerns. For waste activated carbon, sometimes we need a site-specific testing. Generally, for the materials, the likes of sodium chloride, like I said before, it is actually good in dry, rocky, and loamy soil with 85% reduction. The durability is low, meaning it leaches into the soil easily, and the risk to environment is actually very high. When it comes to wood ash, I mentioned one of the challenge, which is there is no standard for wood ash yet, but it's good for moist soil, and 85% reduction. The durability is medium, and the risk to the environment is moderate. Also, when it comes to materials like hydrogel and graphite, tropical and peat soil, it's good there. We have about 44% reduction in resistance. The durability is high and the environmental risk is low. When it comes to zeolite and charcoal, we have a higher resistivity soil, it's good there, and about 94% reduction when tested, moderate in durability and moderate in environmental risks. When it comes to spark plasma, copper, and graphite electrode, it is good for substation grounding. The resistance reduction is high and durability is very high, while the environmental risk is low. Simulation and testing tools. When it comes to grounding system, we kind of predetermine what the grounding system will give us before doing it, and sometimes after doing it over time. That is where simulation and testing tool comes in. We have COMSOL and ETAP, we have FEM and MOM, we have SimGrid, and we have LIBS and machine learning. And this is used for prediction of corruption. That means LIBS and machine learning. Then SimGrid is used for lightning strike safety modeling. Also, FEM and MOM is used to analyze grid design, electrode configuration. Then COMSOL and ETAP is used for precise modeling of soil and gem interaction. That's grounding enhancement material interaction with soil. Optimization strategies of when we want to actually maximize the reduction in the earth resistance, some of the things that have been used over time is the depth and quantity of rods. When it comes to depth, research shows that deeper the rods, the better the reduction. Also, the employment of more rods helps in reducing the resistance up to 70%. Also, the shape of the grids, be it triangular or rectangular, can help reduce cost of grounding system as well. Also, like I said before, simulation tools like ETA reduce copper usage significantly. When it comes to grounding, people don't just go for natural enhancement material, chemical enhancement material. It has been shown that mixture of these two materials gives us greater chance. Like now, for instance, now a research carried out in Unimap using sodium chloride and wood ash. Normally, we know that sodium chloride will leach into the soil in no time, but the mixture of sodium chloride and wood ash made sodium chloride retain the efficiency of the sodium chloride for a longer period of time, and there was less corrosion on the metal. So a mixture of these materials actually gave us better performance in the grounding system. And when it comes to simulation tools, it actually helps us reduce time. It helps us reduce the material cost and elevate design safety to some precision. Then in conclusion, generally, the evolution of grounding systems from conventional steel and copper rods to advanced grounding enhancement materials marked a pivotal shift in electrical engineering safety. Through simulation tools like COMSOL, ETAP, and FEM, and the integration of natural and chemical additives, we now achieve significantly lower grounding resistance even in high resistivity soil. Materials such as bentonite, porphyrin, zeolite, and conductive nanoparticles have demonstrated up to 94% resistance reduction, while LIBS and machine learning techniques offer predictive insight into corrosion and long-term performance. Thank you for your time.
Thank you for the video presentation. Now, I would like to open a Q&A for this paper presentation. So, other participant, did you have any question regarding about this paper? Anyone? Okay. So, if no one, I would like to ask Mr. Banjo. Uh, is it possible to implement an meta heuristic optimization algorithm for this system?
Yes. It's actually very possible to do that because some research carried out in one of my professors at University Tarragano has done it before, just that I didn't include it in this review of the papers. Yes, there's algorithm to optimize grounding resistance.
Okay, thank you for that answer. Okay, so now I will proceed to the next presenter. So I would like to confirm paper ID 50. Are you still here, Dr. Agahya Subia? If no, then I will proceed with paper ID 189. I believe Mr. Ibrahim Alafi, you're here. Can you respond?
Yeah, I am here. Yeah,
Okay. Thank
yeah.
you so
Thank
much.
you.
Sorry for the inconvenience. So I will play your video for this next presentation.
Hello everyone, my name is Ibrahim Al-Lafi. I am pleased to present my research titled Trauma Suppression using the internal model principle at the InECCE 2025 conference. Problem statement. So tremor signal consists of the three harmonic. When they measured from the thumb and index finger and the wrist. So the first harmonic is between 3.5 to 5.8 Hz. The second harmonic is between 6.9 to 11.5 Hz. And the third harmonic is between 10.4 to 17.3 Hz. And voluntary motion is low frequency, less than 3.5, and non-periodic signal, while tremor signal is quasi-periodic signal. So our goal here, we need to suppress tremor signal without affecting on the voluntary motion. The solution, we will use 3 IMBs plus proportional control. Proposed method. So figure 1 shows the block diagram of the tremor cancellation based on the IMB. So we have 3 IMBs plus KB. And IMBs represent this by this transfer function. So B1, B2, B3 is the numerator of the IMBs. So B1 could be KS or S plus K or S squared plus K. So the steps to design the proposed method. So find the geometric average of each tremor harmonic bandwidth, and then find the open loop transfer function LFS. So the open loop transfer function, the controller times G of S. And then we need to tuning the parameter of the controller. And then we plot the void diagram and the NICOS to check the stability. So from the NICOS, the response doesn't encircle the critical point, guarantee the closed loop stability across the tremor frequency range. And the rule of the proportional control uh, to enhance phase margin and improve response speed, especially if the system with slow or the fast dynamic. MATLAB simulation. So we need the transfer function of the plan that represent the glove suppression. So from the experimental setup, we have motor 1 to simulate tremor signal and motor 2 to suppress tremor signal. And the motor 1, motor 2, they are connected by coupler. So we need to find the transfer function of motor 2. So we apply step function step on the function on the motor 2 in open loop mode. And then we measured the speed. So we have input and output, so we can use the system identification technique to find the transfer function. And then we find geometric average for each harmonic of the tremor, and we substitute it in IMB, geometric average 1 and 2 and 3. And when now we need to tune the parameters of the controller K1 and K2 and K3, and then we find them K1 equal 120 and K2 110 and K3 105. So now from the open loop transfer function, we plot the NICOS diagram and the both diagram. So from the NICOS, we can see the curve cover the tremor range. Also, the entire response remain well separated from the critical point at -1 J0, ensure the robust stability across all the three harmonics. And from Boyd diagram, we can see that gain margin 87.1 dB and the phase margin 66.1 dB. This is margin confirmed that our controller design is stable. So MATLAB simulation continue. So we have two signals. The signal from patient 1 and another signal from patient 2. The signal from patient 1 is measured when the resting tremor. So doesn't have voluntarily motion. And the signal from patient 2 is action tremor. It has combined between a tremor signal and voluntarily motion. So figure 3 shows the comparison between measured signal and the output of the algorithm for patient 1. So in time domain and the frequency domain, we can see the algorithm, it cancel the tremor signal here. And figure 4, comparison between the measured signal, input signal and output signal for patient 2. So patient 2 has tremor and voluntary motion. Here we can see from the time domain and the frequency domain, the algorithm just cancel the tremor signal without affecting the voluntary motion. So from the frequency domain, we can see the voluntarily motion doesn't affect here the low frequency, while the first harmonic is cancelled. Performance matrices. So we repeat this on the 10 patients. 10 patients resting tremor and 10 patients action tremor. So this is from 10 patient action tremor. So they have tremor and voluntarily motion. So, and then, so the average preservation of the voluntarily motion for 10 patients was 83%. And first harmonic suppression is 85.3%. And another 10 patients resting tremor, so the average suppression for first set and the second and the third harmonic 88.1, and the second harmonic 81.3%, and the third harmonic 80.8%. Experimental validation. So this is the setup we use to validate the method that we use it here in this research. So we have two motors, as we say. So motor 1 to simulate the tremor signal, motor 2 to suppress tremor. So we have two cases. In case deactivate motor 2, so motor 1, we apply the tremor signal. Motor 1 rotate normal with the tremor, as we see here in figure 7. And when we activate motor 2, the motor 2 starts suppressing tremor without affecting voluntarily motion. Conclusion. So this work presents the method to suppress tremor signal using internal model while preserving voluntarily motion. We use 3 IMPs plus KB, and we use geometric average to tune the parameters of the control offline. And then we use the body diagram and InECCE to check stability. So both simulation and experimental results confirm that the method successfully reduced tremor without affecting voluntarily movement. So developing in future work, we will develop this method for real-time frequency estimation and online tuning controller parameter. Thank you.
Okay. So thank you for the presentation for paper ID 189. So I would like to open Q&A question. Other participant, do you want to ask some question to Mr. Ibrahim?
Thank you.
Okay. So there's no question. Then I will ask. So Mr. Ibrahim, Would you recommend using PI controller instead of just P controller as you have presented?
Yes, yes. So you
Mhm.
can use B. You hear me?
Yeah, I hear you. So you would suggest, would it be more improved than P controller itself, or
No, I use B controller if the system is slow or the fast. So sometimes you can use I internal model is alone by itself.
okay? So okay, thank you for the answer. Okay, thank you very much again, Mr. Ibrahim. So I will proceed with the next presenter. Again, I will call paper ID 50 again. So still no response. Then I will proceed with the next in line. Paper ID 104. Title: The Effect of Data Pre-Processing. The presenter for this paper, are you here in this room? May I know
Yes,
your
I am.
status? Okay, Mr. Yun Chong Liu. Okay, so I will
Yes,
play your video next. Okay,
sure. Thank you.
thank you.
Hello, everyone. The title of our study is The Effect of Data Preprocessing Techniques on the Accuracy of Midterm Solar Power Forecasting. In short, we investigate how different ways of cleaning and preparing solar and weather data impact the accuracy of 3-day ahead solar power forecasts in Australia. As we all know, global energy demand continues to rise each year. Unfortunately, much of this demand still met by fossil fuels, which contribute heavily to greenhouse gas emissions and climate change. Solar power is one of the most promising renewable alternatives, but it comes with a major challenge. It is highly variable. Cloud cover, temperature, and other weather conditions cause big fluctuations in output. For grid operators, having accurate forecasts of solar generation is critical. In particular, medium-term forecasts, meaning about 3 days in advance, are essential for balancing supply and demand, ensuring grid stability and making informed energy management decisions. However, solar forecasting often suffers from inaccurate predictions, and one of the main reasons is poor data quality. Issues like missing values, noise, and outliers. Actually, many previous studies have focused on improving machine learning model architectures, for example, using deep learning ensemble methods or hybrid models. However, very few works have actually looked at the data itself, the data quality side, specifically how pre-processing techniques such as handling missing values affect forecast accuracy. And our research filled this gap. The objective of our research is to systematically compare 7 different techniques for handling missing data. We test this across 3 machine learning models: linear regression, decision trees, and XGBoost, using 2 real-world datasets from Australian solar stations. The goal is to identify which pre-processing technique or approach consistently produces the best forecasting results. Our methodology can be summarized in 5 steps. First, we perform data acquisition by collecting solar and weather data from 2 stations in Australia, one in Ullara and one in Alice Springs. Second, we conduct EDA, exploratory data analysis, where we examine the raw data sets and identify missing values, outliers, and noise. Third, we apply data preprocessing, which includes the 7 different methods of handling missing data, as well as outlier treatment, normalization, and feature selection. Fourth, we carry out model forecasting, using linear regression, decision trees, and XGBoost. We train on 80% of the data and test on the remaining 20% with a forecast horizon of 3 days ahead. Finally, we perform performance evaluation using 4 metrics: mean square error, root mean square error, mean absolute error, and R squared. We use 2 data sets in this study, as I mentioned, one from ULARA and one from Alice Springs Solar Center. The one from ULARA includes data from 2016 to 2014, and the one from Alice Springs Solar Center includes data from 2016 to 2019. And there are also a couple of features, including temperature, wind, irradiance, rainfall, etc. In terms of pre-processing techniques, the most important step is how we handle missing values. We test 7 methods in our research: row deletion, linear interpolation, polynomial interpolation, which is something we use polynomial curves to capture nonlinear patterns, padding, median imputation, mean imputation, previous day's value, where we substitute the measurements from the same time on the prior day. And for outliers, we use the interquartile range method and replace detected outliers with the median. We also normalize all features to the 0 and 1 range, and we use correlation analysis to draw features with very low correlation to power output. The idea is to carefully control for the data quality before training the models. Here is the models that we've tried. As I mentioned before, we tried linear regression, we tried decision tree, and we also tried XGBoost, which is actually our best performer in our analysis. And the forecast horizon, also as I mentioned before, is 3 days ahead in our case. Now let's have a look at the results. Let's see the ULARA data sets at first. For linear regression, row deletion, our first method clearly performs the best with an R-square value of 0.9361 compared to much lower scores for other imputation methods. For decision tree model, the performance is quite stable. For XGBoost, which is an example method, the R-square is now 0.9596, and this is the highest performance observed across all models and techniques for ULARA. For Alice Springs datasets, we can see that the row deletion produced the best results with paired with XGBoost with an R-squared at 0.9738. This is not only higher than the ULARA datasets, but also significantly higher than the results reported in prior studies. For example, a 2023 study on optimized XGBoost for solar forecasting only achieved an R-square of 0.705. To conclude, our study provides 3 main findings. So first one is the row deletion consistently the best pre-processing method. And as I mentioned before, XGBoost in our case is the strongest performer, and pre-processing as important as the model choice. So we actually need to pay extra attention on the data quality side instead of the modeling itself. Looking forward, we see potential of testing more advanced imputation methods, extending the forecast horizon beyond 3 days, and integrating external factors like ground demand to make the predictions even more practical for energy planning. And in the future, we see opportunities for ML-based imputations, longer horizons, and demand integration. Thank you.
Thank you for the video presentation. So I would open a Q&A session to other participants. Is there any question regarding to this presentation? Okay, then I assume there's no one to ask. So, as a sharing, I would like to ask, would you consider a hybrid machine learning for this method? That's my question.
Yeah, that's actually a great question. So, as we mentioned in our paper and also in this video, right? So, in this research, at least on this current stage, we try to pay extra attention on the data itself, on the data quality side, right? But as we all know, right, the hybrid model is definitely, is stronger as it's very powerful, but in our case, the emphasis is to ensure that the good data pre-processing actually can also help to get a better forecast as well. So as I mentioned, a lot of people, a lot of researchers, they focus a lot of attention on the model itself, right? So they're trying to do a lot of hyperparameter tuning. They try to use a lot of advanced machine learning, deep learning, or even hybrid model to try to get a better forecast. But from our research, we figured out which is I believe it is not just an option, but also I would say like a fact is as long as you have the good data, you have a good data quality, or you have a good understanding of how to actually pre-process your data sets properly, then the model is actually the next step, right? Because nowadays a lot of people, they know AI, they know machine learning, they know deep learning, they know hybrid model as you mentioned, but they actually they didn't pay a lot of attention on the data, right? So they probably just got the data sets, they do some very basic exploration on the data set itself, then they may just proceed with the I would say frankly the raw data sets and plug it into the model. Then with how could they actually expect a good forecast, a good result, right? So as I mentioned in our research, we try to persuade others or say try to emphasize the importance of data pre-processing and data quality. But yeah, to answer your question in short, hybrid model is definitely our next attempt, or say the next step for our research.
Thank you so much for that insight. Okay,
Thank you.
so okay, thank you so much. So I will proceed with the next presenter. Paper ID 111. The presenter is Miss Sheda Fariha. Are you here? Hello, can you hear me?
So,
Okay, thank you for the response. So I will play your video next. Thank you.
Assalamualaikum everyone. I'm Soda Farihan Noor. I will be presenting our research titled Comparative Analysis of Hydrokinetic Energy, Photovoltaic and Diesel Generator Systems for Sustainable Rural Electrification. This work, conducted under the Sustainable Energy and Power Electronics Research Group at University Malaysia, Penang. We aim to identify the most viable solution for powering rural areas using renewable and hybrid energy technologies. Let's begin. Electricity access plays a vital role in improving healthcare, education, water supply, and overall economic development. Yet, in many developing regions, including parts of Malaysia, electrifying remote areas remains a huge challenge. Extending the central grid to such locations is technically difficult and economically unfeasible. As a result, diesel generators are commonly used due to their reliability. However, they come with a significant environmental and cost-related downsides. On the other hand, renewable options, especially solar and hydrokinetic energy, have gained attention due to the technological improvements and decreasing costs. In this context, our study compares these three systems using the Homer Pro simulation tool to identify the most balanced solution for rural electrification in Malaysia. To ensure a meaningful analysis, we selected a specific site, Sungai Pahang at Lubuk Papu, which is riverine region with a favorable water flow and solar radiation. Using HomerPro, we modeled three distinct energy systems. The hydrokinetic system used a smart monoflow turbine rated at 5 kilowatt. The photovoltaic system included 15 kilowatt of solar panels with storage batteries, and finally, a conventional 10 kilowatt diesel generator system served as a benchmark for comparison. All systems were designed to meet the annual electricity demand of typical smaller rural community, estimated at 1245 kilowatt hours per year. This table summarizes key configuration and financial details for the three systems. Hydrokinetic systems require a high upfront investment per kilowatt due to specialized turbines and infrastructure. However, they benefit from zero fuel costs, lower operating expenses. The photovoltaic system have moderate capital cost but still depends on costly battery storage and solar irradiance viability. Diesel generators are cheaper to install initially but incur ongoing fuel and maintenance costs which increase over time due to fuel price volatility and wear and tear. All systems were accessed over 25-year project lifespan, which is standard for a renewable installations. When we analyze the economic feasibility of such systems, the hydrokinetic system clearly outperformed the others. It had lowest net present cost at 4,78,562 ringgit and the most affordable levelized cost of energy or LCOE at 2.52 per kilowatt hour RL. In contrast, the photovoltaic system, through clean and modular, incurred the highest capital and storage cost, resulting in an LCOE of 6.37 per kilowatt hour ringgit, more than double that of hydrokinetic. The diesel system offered a middle ground with a moderate NPC, but its LCOE of RM 3.91 is still significantly higher than hydrokinetic, and it's highly sensitive to the rising fuel cost. Over the long term, the economic instability makes it a less attractive option. In terms of technical output, the hydrokinetic system again leads the highest energy production, about 38,000 kilowatt hours per year, far exceeding communities' demand. However, this also resulted in large surplus of excess electricity, suggesting that energy could be either stored, shared, or the load increased to improve utilization. The photovoltaic system generated around 26,000 kilowatt per hour annually, but had a higher unmet load due to intermittency and limitations in battery storage. The diesel generators produced slightly less 22,540 kilowatt hour, but interestingly had zero unmet load. The reliability makes diesel attractive, especially when energy needs are constant, but again, this comes at the other trade-offs as we will see next. One of the strongest arguments in favor of renewable system in the environmental benefit, both hydrokinetic and photovoltaic systems operate with zero direct carbon emissions throughout their lifetime. In contrast, the diesel generator system emitted nearly 28,000 kilograms of carbon dioxide per year, along with other harmful pollutants such as carbon monoxide and nitrogen dioxide. Diesel systems also generate noise pollution, depend on an extensive fossil fuel supply chain that includes extraction, refining, and transport, all of which contribute to ecological degradation. In remote communities where agriculture and nature are intertwined with livelihood, maintaining environmental integrity is just as important as supplying electricity. To conclude, hydrokinetic energy offers the best balance of cost, performance, and environmental sustainability. particularly for locations near rivers and streams, where photovoltaic system is emission free. Its high cost and dependency on sunlight is limit its utility. Diesel remains reliable but carries high long-term costs and environmental penalties. These findings can guide policymakers and engineers in selecting appropriate technologies for rural electrification. We extend our sincere thanks to University of Malaysia Pahang Al Sultan Abdullah for their support through internal grants. Thank you for your attention. We now welcome any questions or feedback you may have.
So, so I guess thank you for that video presentation. Then I open a Q&A session for other participant or anyone to answer to ask some question regarding to this research. Is there anyone? I guess I guess no one. So I will personally ask some question. Regarding about the emission, would you consider the emission, for example, like in production of photovoltaic panel? Because during the production, there will be some emission due to the material itself. How would you say about this?
Sorry, could you repeat the question again? I couldn't understand.
Okay, regarding about the emission or we say about the uh, regarding about the emission that you have stated about the hydroelectric, photovoltaic, and diesel, would you consider an emission during production, the production of the component itself? For example, like photovoltaic panel, during the production of the PV panel itself, can cause an emission due to the material itself.
Oh, yes, that will cause emission, but we haven't considered it in our system. Our system only considers the we have built in Homer Pro, we have built particular systems to compare the load and emissions, but not in the production process of the PV system, photovoltaic itself. So we will consider. I think it will be one option to consider.
So I guess thank you for the answer. Thank you for the insight. So thank you very much again. Okay, so I will proceed with the next presenter. Paper ID 223. Let me confirm your status in this meeting. Um, Titled A Novel POESC Consensus Mechanism.
Hello, can you hear me?
Yes, I can hear you
Yeah,
well.
I'm here. Yeah,
Okay,
I can.
okay,
Yeah.
thank you for your response. So I will play your video next.
Okay, thank you.
Thank you very much.
Hello everyone, my name is Mayank Arora and today I'm going to present my paper titled A Novel Proof of Energy Authentication and Contribution Consensus Mechanism for Decentralized Energy Trading System. My paper title is 223 and these are my supervisors and we are from IIT Kanpur and La Trobe University in Australia. This is a basic outline of my presentation which I'll go through as I'll progress in my presentation. Starting with the abstract. Since we already know that everyone is installing solar PV panel on their rooftops just to make sure that they can sell electricity to the grid. But there's a fashion that is being changing right now. People, instead of selling electricity to the grid, they are selling electricity to their neighbors, which is making us a decentralized energy trading system. Hence, it need to be fair, secure, transparent energy trading mechanism. For this, we introduce a proof of energy authentication and contribution, which is a novel method, which authenticate that this specific resource, like a solar panel or battery or the wind, belongs to this specific prosumers. And in case such as if the government will say that they will give subsidy on the solar PV panel generation of electricity, So customers or the prosumers can't fake that this electricity is being generated from the solar panels. For this, we need a proof that this electricity is being generated by solar panel. That's why there's a need to develop this method of ours, which was proof of energy authentication and contribution. Although there are various methods in literature like proof of work, proof of stake, and so proof of elapsed time. So in this case, we need to compare our method, which is being different as compared to already existing methods. No methods in literature says that there is a specific resource which the prosumer has, and we need to verify that so that they can just do energy trading. That's why there was need to develop this kind of approach, which uses verification with the help of digital signatures and zero knowledge proof, and which is secure and privacy friendly also. That makes a market that makes it different as compared to the existing methods which are already there in the market. Coming forward, we have taken 4 prosumers in this case over and just taken their generation and consumption data, which is varying over 24 hours of duration. In this case, the outcome was a sustainable and auditable energy trading models that rewards contribution and supports grid stability. It provides a foundation for scalable, secure, decentralized energy ecosystem. This is the basic architecture of our model, in which our bottom layer is our authentication module, which authenticate that these 4 prosumers have these assets, and it gives them a public keys and asset certification. Next stage, the middle stage, is a contribution verification module, which verify that this prosumer is verifying this much amount of electricity or not. And the last one is consensus algorithm. If they are able to do that, then they are allowed to do energy trade in the system, and that specific records will be stored onto the blockchain platform. There are few assumptions which we have taken for this study. There's a genuine and functional energy assets, secure cryptographic protocol have been, in this case, been used. Data reliability requirements. So energy production, consumption, and storage is being taken into consumption, that this is a real-time data, because we have used the MATLAB software generation, which uses a real-time electricity energy generation from prosumer end. Then there comes data sources. In this case, that is what I said, MATLAB-based home load generator, which is available in paper number 9. For simulation, we have used. This is a mathematical modeling in which each prosumer signs that this asset belongs to them. Then it is being verified and allotted a public key. Then we are just using a contribution proof, collect the energy data, generate the proof for that. Then the consensus algorithm is being used to verify and add that transaction to the ledger. Energy balance is being used. For example, this much an amount of energy is being remaining after generating, after consumption, after sharing. So this much amount of energy is being left over with the prosumers so that they are eligible to do a trade into the market or not. And hence the proof of contribution is being calculated, and based upon that, they are allowed to do trades in the future. So these are simulation results. These are total energy production consumption over time for all the prosumers, and this is for the individual prosumers. This is energy trade or the transactions happening from prosumer number 1 to all the prosumers. Similarly, prosumer 2 for with all the prosumers, prosumer 3 with all the prosumers, and 4 with all the prosumers. Because at different time interval, they will trade with all the prosumers. So it can be a bidirectional amount of flow within the network. We have compared our model with already existing models like a proof of stake, proof of elapsed time, in which we have seen that throughput was 120 transactions per second. Latency was less as compared to the already existing models. Gas fees was also less as compared to already existing models. These are security tests which we conducted, which we have seen that if the prosumer has, for example, insufficient amount of electricity, so they are not allowed to trade. And if insufficient balance, they are not allowed to trade. If there's zero energy production, unauthorized state, they are not allowed to trade in the system. That means a proof of energy authentication contribution works as a gatekeeper for valid energy activities in the system. To conclude, the proof of energy authentication enables a secure, transparent energy trading in the decentralized system. It combines the cryptographic authentication and real energy contribution verification. It ensures only the legitimate active prosumers can validate or contribute to the energy trading system, which is already there in the market. There are few limitations like zero knowledge proof and digital signatures overhead may limit the scalability if we want to scale this to the larger network. It depends upon the accuracy because when we implement this in the real life, so how much accurate it is based upon the real life smart meter datasets, which we will acquire in the future as a future work. Prototype has not been tested. For example, if there's a cyber attack onto the smart meters, we have not tested that model onto that system. So maybe in the future, we're going to test this into the larger scale as well as we're going to test this in the real-time network, for example, real-time smart meters with adding a cyber attack into the system, and then compare this specific method. For now, this is successful that if some prosumer is having a real energy being generated from the solar panel, they're allowed to trade into the system. That's where proof of energy authentication and contribution plays a major role in deciding whether this is a good prosumer and this is a bad prosumer. So these are some set of references which we have taken into consideration. And thank you for listening peacefully. So I'm open for any question and answers if you have any.
Okay. Thank you for the video presentation. So I would like to open the Q&A session for others to ask Mr. Mayang for any question. Anyone? So I guess no one. So I will ask one question regarding your project. So
Sure.
so would you consider an application of AI in your research?
As of now, I have not considered any application of AI, but it can be expanded with the application of AI because everyone is integrating AI. Like we already know ChatGPT, Perplexities, DeepSeek. So we
Yes.
can easily add it on like based upon ensemble learning detections.
Yes. Okay. Okay. So I guess thank you for the insight. So thank you so much. So
Thank you so much.
yeah, I will proceed with the next presenter. Okay. So next in line is paper ID 66. Title Suspension Insulator String Parameters Analytical Calculation Based on Potential Distribution. So I want to confirm the status of this paper presenter. Are you here in this room right now? Can you hear me? Can you respond? Mr. Alexander. Mm,
Yes, I'm here.
okay, thank you for the response. So I will play your video next. Thank you so much.
Okay, thank you. Good day. I am Alexander S. Carrascal from the Polytechnic University of the Philippines. Title of my presentation is Suspension Insulator String Parameters, Analytical Calculations Based on the Potential Distribution. My presentation covers the research problem, objectives, methodology, results, and conclusion. For the research problem, I will cite the main problem statement. This study considers a research gap, the inverse problem of the voltage distribution along the suspension insulator string, and its explicit and closed form solution. Specifically, we seek to answer the following questions. 1. Given a complex voltage distribution along an insulator string and the values of the stray parameters, can we compute the self-capacitance and resistance values of the disk insulators using an explicit formula? 2. Given a complex voltage distribution along an insulator string and the self-capacitance and resistance values of the disk insulators, can we compute the values of the stray line and ground capacitances using an explicit formula? The answers to these questions are affirmative, and I will show the formula in the next slides. The said formula can be used for analysis, design, and optimization of insulator string parameters to achieve a desired voltage distribution. For the objectives, let me mention the general and the specific objectives. The general objective is to solve the inverse voltage distribution problem along the insulator string, which may be stated as: given a voltage distribution and any two of the three parameters, which are the line capacitance, ground capacitance, and self-capacitance, determine the third parameter. Specifically, given the voltage distribution, we aim to derive the following. 1. Formula for line capacitance, provided the self and ground capacitances are known. 2. Formula for ground capacitance, provided self and line capacitances are known. 3. Formula for self-capacitance, provided line and ground capacitances are known. For the methodology, we shall discuss briefly the procedure, modeling, and the formula. The procedure consists basically of 4 steps. 1. Construct the equivalent circuit of the insulator string. 2. Write the system of equations using Kirchhoff's current law. 3. Express the equations in a form suitable for deriving the formula. 4. Manipulate the equations to derive the formula. The figure on the right is the equivalent circuit or lamp parameter model of an insulator string. The insulator string consists of insulator discs that are chained together in a series manner. Each insulator disc is represented by a self-capacitance. The presence of the tower and the line conductor causes stray capacitances to exist between the insulator disc, the tower, and the conductor. Stray capacitances are responsible for the non-uniform distribution of voltage that results in the disc nearest the conductor to receive the highest electrical stress, which causes flashovers. We obtained a mathematical model of the insulator string by applying Kirchhoff's current law at each junction connecting the disc. As a result, a system of recurrent solutions or difference equations is formed. The difference equations are first order if we regard the disc voltages as the unknown, and the second order if we treat the disc admittances as the unknown. Most research and published papers dealt with the forward problem, which is the calculation of voltage distribution given the insulator string parameters. In this study, we dealt with the inverse problem, which is the calculation of the string parameters given the voltage distribution. We can also regard the system of equations as zero-order difference equations if we regard the string parameters, either the line capacitance or the ground capacitance, as the unknown. Depending on what quantity is considered unknown, we can transform the system of equations into a suitable form and find the unknown. From the matrix form of the solution, we can obtain the summation form of the formula. For the results, we discuss and derive the key equations and formula. This slide shows the formula for computing the line capacitances. The first formula gives the line capacitance for a given complex voltage distribution, ground capacitances, and complex disc admittances, which results when the disc insulators are contaminated and have finite resistance. The second formula gives the line capacitance for a given real voltage distribution, ground capacitances, and imaginary disc admittance, which is the case when the disc insulators are clean and have infinite resistance. This slide shows an example for computing the line capacitance given a clean string with a real voltage distribution and uniform self and uniform ground capacitances as listed in Table 1. The values listed in Table 1 were substituted into the indicated formula to compute the values of the line capacitances that are listed in Table 2. The graph on the left shows in percentage the real voltage and potential distributions used in the previous example for computing the line capacitances. The graph on the right shows the given self-capacitances and ground capacitances and the computed line capacitances in the previous example. This slide shows the formula for computing the ground capacitances. The first formula gives the ground capacitance for given line capacitances, a complex voltage distribution, and a complex disc admittance, which results when the disc insulators are contaminated and have finite resistance. Second formula gives the ground capacitance for given line capacitances, a real voltage distribution, and imaginary disc admittance, which is the case when the disc insulators are clean and have infinite resistance. This slide shows the formula for computing the disc insulators admittances. The first formula gives the insulator admittance for a given complex voltage distribution, ground capacitances, and line capacitances, with the admittance of the first disc also specified. Second formula gives the disc insulator complex admittance for a given complex voltage distribution and stray parameters, with the admittance of the last disc also specified. This slide shows two formula. The first formula gives the disc insulator self-capacitance for a given real voltage distribution, ground capacitances, and line capacitances, with the self-capacitance of the first disc insulator also specified. Second formula gives the disc insulator self-capacitance for a given real voltage distribution and stray parameters, with the last disc insulator self-capacitance also specified. For design purposes, we can use this formula in computing the optimal values of the disc insulator self-capacitances that will result in a desired real voltage distribution. This slide shows an example of computing the disc insulator self-capacitance given a clean insulator string with a real voltage distribution, a uniform line capacitance, and uniform ground capacitance as listed in Table 3. The values of the quantities listed in Table 3 were substituted into the indicated formula to compute the self-capacitance values. The computed values of the self-capacitance are listed in Table 4. The graph on the left shows the desired real voltage and potential distributions in percentage. The desired voltage distribution is uniform, resulting in a linear potential distribution. The graph on the right shows the computed self-capacitance and the given stray capacitances for the sample insulator string design. For the conclusion, we give some important remarks. The inverse problem of the voltage distribution problem along a suspension insulator string has a closed form solution, which we can express as explicit formula in summation form. We derive the formula to compute the insulator's string self-capacitance and stray capacitances for a given potential distribution. We also derive the formula for computing the stray capacitances given the potential distribution and the self-capacitance. Thank you, and this ends my presentation. Good day, I am Alexander S.
Okay. Thank you for the video presentation. So I would like to open a Q&A session for the participant to ask regarding about this research. Is there any question? Okay. So I guess there is no question for other participants. So I will personally ask one question. Does this model, the calculation model, are applicable in both balanced load and unbalanced load? That's my question.
Yes, actually the model is very general. It is based on the lamp parameter model as opposed to what is used in most simulations, which is based on the Maxwell's field equations. So this particular model is applicable to any situation, any case. Yes.
Okay. Thank you. Thank you for that insight. So, and thank you very much for the response. Thank you. Next, I will
Thank you
proceed
also.
to the next presenter. All right. Thank you. The next presenter paper, before that, I would like to double confirm. Does presenter for paper ID 50 already here in the virtual room? So I guess the presenter is still not here, so I will proceed with the next in line. Paper ID 226. Title prompting generative LLM for inconsistent Thai question generation. Are the presenter here?
Yes, I'm here.
Okay, thank you for the response. So I will proceed. I will proceed to play your video next. Thank you.
Hello, ladies and gentlemen. Today I will present the research topic about prompting generative LLM for consistent Thai equation generative via symmetric retrieval. My name is Kitwaran Tana Opat. I come from Prince of Songkla University, Thailand. My outline for today presentation: the first, introduction; the second, research objective; the third, methodology and evaluation; the last one, conclusion. In introduction, the state of the art, the Thai question and answer challenge with the generative LLM for the rapid model and growing fast and rapid than generative LLM to challenge with the question and answer accuracy and performance. Motivation for Thai QA system develop. Why move the executive to generative LM method? The gap of research. The gap of research Thai question generation have the limitation and other limit about model and complex in Thai and Asian language. The second topic about the research objective. The research objective on this research, we have three objectives. The first, propose generative question and answer with prompt tuning LM. The second, integrate the symmetric retrieval via Facebook AI symmetric research. The last one, introduce semantic matching accuracy, the SMA the methodology. My methodology about this research, we talk about the first system overview and the second Facebook AI similarity search-based retrieval, and the last one generative LLM and prompting strategy. The system overview, we use the Thai Wiki dataset from question and answer from Thai Wikipedia. We have the 1,700 questions. We make the Facebook AI similarity search index for create with the bird model. We selected the 3 model from bird, Wangjan, Parapet, and Payathai to make the sentence embedding model. And we holding the model for check the similarity by using the SMA semantic matching accuracy from the generate question with the generative LLM with prompt, and we show result and present the result in the evaluation topic. From the Facebook based retriever, we use the Cogen BGE M3 Payathai bird and Wangjan bird, and the second Parapet multilingual InECCE. The 3 model popular in Thai language research, accuracy and performance with the Thai language. And prompting strategy and generative LLM model from our scenario, we select the generative LLM. In prompt strategy, we use the basic prompt compare with the few shot and chain of thought, COT, and low bait prompting. From our result in evaluation, the first we show the result from Cogen Payathai with the 4 scenario on prompt type, instruction bait, few shot, COT, and low bait. When have a better performance and SMA accuracy, high accuracy matching more than 80% and higher to 95 from Payathai model. In the model from Facebook AI similarity search to check the generate question and the original question. And the second one, Parapet multi-language MNet based V2. MNet V2 the same performance with when 2.5 in Thai generate question, same SMA performance more than 80% compared with the other model from graph can show Llama and Llama Chat QA and Granite. The when 2.5 higher than same the first result from Payathai, and the last one in figure 4 Cogen from Wangjan bird. The LM from Thai language. Same result, the high SMA value, the matching accuracy, same. The first and second LM model from Facebook AI similarity search with bird more than 80% for its prompt strategy. For our conclusion with research paper, this research we can propose the system about the generative question and answer framework in Thai language by using the Facebook AI similarity search retrieval with prompt driven LM and prompt strategy. Key finding from this research, Quen and Granite outperform than specific LM model with QA 8 billion that can show about the lightweight, from instruction-based pumping have a high similarity and same like COT pumping in Thai language and generate question method. The prompt design the significant low and perform well designed. The prompt can consistently the result within the prompt have a more difficult and more contract the resources from instruction based is the right way and COT has a more and complex chain from pumping make a more resources and make a more time for execution. If overall the result can show COT is not have a performance than instruction based because prompting in nowadays is not different for complex and simple phone prompt can make the same answer like Asia language. Thank you for attention. Now question and answer. Thank you. Hello, ladies and gentlemen.
Okay, thank you for the video presentation, Mr. Kritwara. So I open Q&A to others to regarding this research. Is there any question?
Again for the question. Again, please
Okay.
for the question.
Okay, I think I will ask you the question myself.
Oh, okay.
So what is the future implementation? I mean, does this model will be implemented in mobile phone or browser or anywhere else?
Oh, okay, okay. Now platform for any social interface can Line chatbot and WeChat and other and it from same the platform API hook for any platform
Anytime. Okay.
for AI side. Yeah.
Okay. All right. Thank you for the insight. Thank you so much again.
Thank you.
Then I think we will proceed with the next presenter. Okay, thank you so much again, Mr. Kirwara. I would like to call paper ID 84. Somehow I missed your paper. That's title Real-Time Equality Monitoring. By presented by Mr. Kazim Ali. Are you here in this session?
Yes, I'm here. So
Okay, thank you.
yeah, I was like
Okay.
happens to be the next ones but you actually missed it
I'm so
probably.
sorry for the inconvenience. Okay.
It's all right.
Okay, so I
Yeah.
will play your video next, all right? Okay, thank you.
Good day. I am Alexander.
Hi everyone. My name is Dr. Kazim Ali. Um I, I'm teaching associate from the Department of Chemical and Environmental Engineering at the University of Nottingham in the UK. This paper is in collaborations with Obafemi Awolowo University, Ife, the Department of Chemical Engineering and Chemical Engineering. So the main authors of this paper is Professor A.S. Osholeke, and I happen to be one of the co-authors of the papers, and here to give you presentations on the real-time air quality monitoring using artificial intelligence and Internet of Things. So this presentation explores how real-time air quality monitoring is revolutionized through artificial intelligence and the Internet of Things. Main, let's say 5, if time permits, I'll cover the 6 elements of that. So I'll cover main topics, which is the why the need for the real-time air quality monitoring. I will look into the overview of the IoT, the basic overview of the AI and the IoT technologies. Then I will dive into the methodologies. We will look into the results, explains the results of the case study, and if time permits, I will look into the challenges and the future perspectives of the AI and IoT. let's delve into the real questions, which is research problems, why the need for the real-time air quality monitoring. So we all know the air pollution faces significant problems, public health risks, to the worldwide. So the traditional monitoring methods have limitations, yes. And in terms of the accuracy, the timely data is very essential to protect the communities and inform the policy decisions. Then that takes us to the background knowledge. What are the features of the traditionals, the conventional air quality monitoring that is in use at the moment? And what are the features of the real-time air quality monitoring? When the data, another feature is the data collected is at intervals, and it's often analyzing at offline. And again, it uses high precision instruments like gas chromatography and mass spectrometers. And these are highly to maintain, and they are being run by only the governments or academic institutions. But when it comes to the real-time air quality monitoring, they make use of the IoT sensors, mobiles, and the distributors capable of continuous live data transmission, often integrated with the AI for analysis and predictions. And the data are accessible at any time through the hubs, dashboards, and the like. So then I have some kind of summarizations of the difference between the two over here. And then again, like I said, air pollution is a major problem. It's a major health challenges we have, and that's why we are proposing the real-time air quality monitoring. The causes respiratory, cardiovascular diseases, premature deaths, and the likes. So India pollutions is another thing, which from solid fuels approximately cost about 3.2 million deaths annually in Nigeria. And some of the key sources are the industrial activities, the vehicular emissions, and the energy use. And then so let's look at the limitations of traditional air quality, conventional ones at the moment. Air quality, the conventional air quality monitoring. So three things I make mentions over here. They provide a high cost of maintenance of the stations. There is a sparse sensor distributions and the data availability. Again, let's look at real-time air quality, the advantages of real-time air quality monitoring. So three things I will make mention over here. So they provide a wide coverage, they provide a public awareness, and they provide a continuous live data transmission. And when it comes to the overview of the high AI and the high, there are two different things. They have both transformative technologies for environmental sensing, offering enhanced data collection, analysis, and actionable insights. So AI on its own provide four key things advantage. So they process a kind of patterns on the data as well. They can predict based on the data. They can form some kind of predictions, and you can optimize the monitoring process. And again, when you look at the key components of the Internet of the Things, they are the interconnected society, communications networks, and the cloud platform. If time permits, I'll be able to explain this because I'm running off short. When we talk about the methodology we employed, so understanding the systems design is essentials, and for deploying effective air quality monitoring solution using air and IoT. So we make use of in these methods, we make use of historical data of the air quality data. We got that from the Kaggle that comes in terms of the AI model. We use that as historical model, and we built some kind of air quality monitoring system through the dashboard, through the sensors. So we make use of MQ7 sensors and the IoT quality monitoring. So we make use of ESP8266 to deploy to obtain real-time data of the IoT. So, and in terms of the data transmission and cloud integrations, so yeah, it depends on the we make it in terms of the cloud infrastructures. We make use of the Think Speak server and to store our large data, and we run here. We make use of four different algorithms model. These are the linear regression, the artificial neural networks, the long short-term memory, and the k-nearest neighbor models. So the essence of these is we use all these algorithms to analyze the data to identify the pollution sources, predict the air quality trends, and visualize the information for our conclusion. And again, so the applications we apply to the PM 2.5 real-time air quality monitoring. Yeah, like I was saying, when you make use of using Python, the dataset was partitioned into the discrete trainings and testing subset. The training set forms the bedrock for model training, while the test set assumes a crucial roles in evaluating the precisions of all the models. You make mentions, or if you remember, we make use of the linear regressions here and then the LSTMs and the KNN. So here are the results. The first one over there. So we use 4 different measures where we can see that the mean average error, the mean square, the root mean square, the root mean square error. So the root mean square and R square. So R square happens to be the overall evaluations of the performance of all the models. So the linear regressions over there. So at the end of the day, we have the R square for the linear regressions, and here's a pictorial views of what a linear regressions value looks like. And here is the head end, and where is the R square for that. And here it's the pictorial representation of that. And we have the LSTM with the long short terms memory, which happens to be the best accuracy of the half square we have over here, which is the one over here. And then we have the KNN as well. We have the half square for that, which is the last one over here. So from there, you can see that the LSTMs happens to be the most reliable or accuracy we resolve at. The root sense monitoring importance, the role of the AI and IoT, and the future innovations and collaborations. So if you
Hello, ladies and gentlemen. Today I will present the
Okay, I guess that's the end of the video. Thank you again for the video presentation. Now I open for Q&A session from other participant. Did anyone have any question regarding to this presentation? Okay, I guess there's one. So I would like to ask one question regarding to this. So did you implement mobile apps for this research so you can monitor it conveniently?
Yeah, so that's one of the sensors. It's we can't call it because it's really installs on laptops, so we can call that as a mobile, but we're still working on that to improve on that so that we can have access on phone as well. Yeah.
Okay. Okay. Thank you for the answer. So thank you again, Mr. Kasim. Then I will proceed with the next presenter.
All right. Thank you.
Right. Thank you. So the next presenter will be paper ID 239, title FGSM attack impact on InECCE classifier via PyTorch Lightning. The presenter, Mr. Albrecht. All right. Okay. So I will play your video in next. Thank you.
Good day, everyone. I'm Elbren O. Antonio from the College of Computer Studies at Sultan Kudarat State University. It's an honor to be part of this conference and to share with you my research titled FGSM Attack Impact on MNIST Classifiers via PyTorch Lightning. This work explores how even highly accurate models like CNNs, often seen as reliable and powerful, can be surprisingly vulnerable to simple adversarial attacks. Specifically, we investigate the fast gradient sign method and how it affects classification accuracy using the well-known MNIST dataset. Through this presentation, I hope to highlight the importance of not only building intelligent AI models, but also making them robust and secure against exploitation. CNN are powerful tools in AI that can automatically learn features from raw image data. This ability makes them ideal for visual tasks like facial recognition, handwritten digit application, and medical imaging. A typical CNN processes an image through several layers, detecting edges, reducing dimensions, and making predictions. It's like teaching a machine to see patterns and make decisions based on what it observes. From smartphone face unlock to disease detection in X-rays, CNNs are now part of many technologies we use every day. CNNs are known for their speed and accuracy, powering everything from medical tools to self-driving cars. But their high performance hide a critical weakness. They can be fooled by tiny invisible changes in input images. Imagine a self-driving car confidently recognizing a stop sign. With just a slight undetectable tweak, the model suddenly misread it as speed limit sign. That's how fragile these systems can be. In my research, I focus on this hidden threat using a technique called Fast Gradient Sign Method, or FGSM, a simple yet powerful way to reveal how vulnerable CNNs really are. I'm not here to discredit CNNs, but to expose the risk we need to address, especially in fields like healthcare and autonomous systems. Ensuring reliability is not just important, it's critical for safety and trust. CNNs are powerful, especially in image recognition, but they're not as flawless as they seem. One of their biggest weaknesses is how easily they can be fooled by what we call adversarial examples. These are inputs that look normal to us, not blur, not distortion, but have been slightly altered to mislead the model. For example, the image on the left clearly shows a bird, yet the CNN misclassifies it as an airliner with over 98% confidence. This is caused by a perturbation, a small, calculated change in pixels values. It's not random, but carefully designed to exploit how the model sees data. Now imagine this in real life. A self-driving car misread a stop sign, or a security system fails to detect an intruder. In areas like healthcare, finance, or public safety, small attacks like this could have serious consequences. That's why, in my research, I aim to show how easily CNNs can be manipulated, and why defending against adversarial attack is critical as AI continues to evolve. Now that we've seen that CNN can be fooled, let me explain how. In this study, I used the fast gradient sign method, a simple, fast, and surprisingly effective attack technique. FGSM works by calculating which direction would confuse the model the most. Specifically, the direction that increases the model's loss. Then, it slightly tweaks its pixel of the image in that direction. These changes are tiny and invisible to the human eye, but they're enough to trick the model into making a wrong prediction. If you look at the 3D graph, you'll see how it is worked. The clean image start at the bottom, correctly classified. FGSM takes one calculated step forward, following the steepest slope, and suddenly, the image is misclassified with high confidence. What makes FGSM dangerous is its efficiency. It doesn't need retaining or complex processing. Just one gradient step. That's all it takes to fool even advanced model. In this research, I used FGSM to reveal how fragile CNNs can be, and why building robust, secure AI system must be priority. This slide shows how deceptive adversarial attacks can be. On the left, we see example of two fighter jets images that look identical to us. But to the model, subtle pixel changes completely alter the prediction. The heat map on the right revealed those hidden changes, called perturbations. They're not random. They're strategically calculated to fold the model using methods like FGSM. What's alarming is that this manipulation only takes one computation steps. Yet, it's enough to mislead even advanced model. This graph shows how a CNN performs during training. The yellow line tracks accuracy on clean data. It improves steadily and reaches about 95% by the 10th epoch. There is a clear 9% gap. Clean accuracy at 95%, FGSM at just 85%. And this graph also compares the model's loss on clean data versus adversarial data over 10 epochs. This means the yellow line shows clean loss. It drops steadily, meaning the model is learning well, but the orange line representing FGSM loss stays consistently higher. Then it improves slowly but never reaches the same low level. To conclude, this study reminds us that while CNNs are powerful, they're not invincible. Even the slightest adversarial tweaks, invisible to the human eye, can cause them fail. Moving forward, developing models that are not only smart but also resilient will be essential in building safe, reliable, and trustworthy AI. Thank you everyone and good day.
Okay. Thank you for the video presentation. So now, I open for Q&A session from other participant if you're interested to know more about this presentation. Is there any question? Okay. Again, so I would like to ask some question if no one want to ask. Um, in this study, how many variety of images that have been tested to prove the accuracy of this model? That's my question.
Hello, good morning. Hello, good morning, sir.
Good morning.
Okay, actually, we are using the whole InECCE dataset of the available dataset provided from the MNEST. That is a available dataset. So that is just one. That is one dataset that we are tested, but we are trying to test. That is almost 70,000 images more. So we divided that into like 60,000. For the tested is 10,000. That's all. So there are so many available data we tested, but we just use only the MNEST dataset for that testing, so that we can test if GSM is truly applicable on manipulating the result of our training, especially in looking through those cameras on how they treat the available images we captured.
Okay. 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 Thank you for the answer, and thank you so much for your participation in this virtual room.
Thank you.
So I would like to proceed with the next paper. Next in line is paper ID 240, titled Pre-file Enhancing Learning Mechanism Using AI Integration. So, does the presenter already here in the virtual room? Can you give some response?
Sir. Yes, sir. Good morning.
Okay, I see you. Okay, thank you for the response. So I will play your video in short. Okay, thank you.
My name is Vidit Mehta, and I am presenting my research on Propel AI, enhancing learning mechanism using AI integration. This work has been carried out under the guidance of Dr. Anu Sharma as co-author at PES University, and it is being presented at IEEE 8th International Conference on Electrical Control and Computer Engineering. Rappel AI is an AI-driven platform designed to make learning more personalized, structured, and efficient. The system breaks down the complex topic into manageable subtopic, generates AI-powered flashcard, applies space repetition for better memory retention, and track user progress over the time. With curated resources and innovative roadmap, it helps both students and professionals achieve their goal more efficiently. This research focuses on leveraging AI to transform the way we approach self-paced learning. In today's fast-paced environment, learners struggle with two main challenges: managing such study schedule and retaining vast amount of information. Traditional learning method lack of personalization and adaptability. This often lead to insufficient time usage and difficult to remember all the topics and breaking them into smaller parts. With the absence of memory reinforcement technique, we ultimately result in reducing long-term retention. The purpose of Propel AI is to deliver a fully personalized learning experience based on learner's goal, time constraint, and preferred learning pace. It improves memory retention through AI-powered flashcard and space repetition techniques, simplify complex topic via structured roadmap, and boosts study efficiency with progress tracking, curated resources, and optimized scheduling. Our research target both student and the professional looking for customized learning solution. The platform supports the wide range of subjects for academic course to professional skill development. It uses AI to generate tailored study plan, roadmap, and flashcard used for user input. However, it does not provide live tutoring. Instead, it focuses on tools and strategies for efficient self-learning. As of now, there are two platform working on same mentality, that is Quizlet and Brainscape. Quizlet is flashcard-based learning for diverse subject, and here we have a predefined sets of flashcard or limited flashcard which are there, or you can create a manual creation of your own flashcard on the topic you want to learn. Limited to text-based input only, as well as there is no AI/ML integration. Whereas in Brainscape, there is flashcard learning, but which is working with spaced repetition for better retention of the knowledge, moderate or uses of conversative science for pacing studies, and focuses on text and multimedia limited. Whereas in Prepel AI, we have personalized study panel as well as AI generated flashcard, which is fully tailored according to the user, how much time he or she wants to work or complete that particular topic. On that basis, a fully tailored structured roadmap will be created, and from that flashcard will be generated, and that will help them. And it is depending on the user's input, which is fully generated by AI. So these are the basic exceptions that Prepel have that is helpful for education, as well as we supports different type of documents like image, PDF, and text-based documents you can upload to get a full flashcard or roadmap. Our proposed methodology is that follows step-by-step AI-driven approach. It starts with user input. The learner specifies their goal, available time, and preferred pace. A locally deployed fine-tuned Falcon 7B instruct model processes these data to generate hierarchical learning roadmap based on the topic complexity, and adaptive schedule is created, integrating revision cycle through spaced retention and active recall using flashcard generated from the roadmap. The system also send reminder and dynamically adjust schedule based on progress. Technically, the backend use MongoDB Atlas for scalable storage, while the front end is developed using React and React Native for mobile access. AI integration is achieved using OpenAI for content summarization, flashcard creation, and study roadmap generation. This is the proper module functionality that we can say that Prepile AI include model for user registration, content upload, roadmap generation, automated flashcard creation, progress tracking, scheduling, and resource recommendation. Each module is designed to work seamlessly, creating a complete personalized learning ecosystem. Here we can see that we have three options. Either he can upload the content, he can provide with the topic, and either he can provide topic with the time, which will generate a fully tailored roadmap with time. The main module functionality that I have explained are as follows: that we can create roadmap, we can generate flashcard, progress tracking, task scheduling, and many more things are there. This is the architecture diagram. This architecture diagram illustrates the system components and their interaction from user input to AI processing, backend management, and front-end delivery. Everything is being displayed. Like we have a presentation layer, service layer is the API to the OpenAI and AI ML model, that is Falcon 7B Instruct. Security layer is encryption, authentication, secure data storage, which is later on connected with data layer like user flashcard, user roadmap, user progress update. Everything is being stored in cloud, that is MongoDB Atlas. These are the screenshots of web application. Here, this is the basic welcome dashboard, which shows that what is the goal or go we can create your study plan. And below is the progress that will help you know that how much you have completed the part. This is the flashcard creation. Here we have flashcard, we can download it, we can save it. This is the proper roadmap in different cycles, that every roadmap have its own flashcard, and you can export as PDF or you can save it in the cloud. So initially, testing showed that 21.4% improvement in flashcard retention was there, and average quiz score also improved by 15 points, or increase in study consistency and higher competition rate of panel study session when compared to the traditional learning method. We can see that there is a rise in the performance of the group of the student who were using PrepL AI as compared to the group of the student who were just working with the normal notes and everything. And Propel AI can help student prepare for exam with tailored study plan, assist professional in upskilling, enabling researchers to summarize complex content efficiently, helps lifelong learner manage their time better, and integrate with online education platform for enhancing e-learning experience. The major future enhancement that can be the part of the project will be multilingual support. As we have just English as a basic language, we can work and we can adopt a local LLM which is going to do the machine translation. We can also work with AI powered quiz to understand how much knowledge the person have gained, and this will help us to know that how he or she is able to retain the knowledge whatever that has been gained. And group learning features, these are some features that we're going to add so that multiple people can start learning a same topic as in a group. The future improvements include expanding the AI model domain knowledge, integrating voice-based interaction, enabling multilingual support, and adding analytics dashboard to give learner deeper insight to their progress. So this is what Rappel AI is all about. Thank you for your attention. I am now open to any questions for the panel or audience.
Okay, thank you for the video presentation. So now as usual, I open a Q&A session for 2 minutes. Is there any other participant that want to ask regarding this presentation? Anyone? Okay. As the chairperson, I would like to ask one question. Um, Regarding to this application, is it mandatory to have an internet, or can it be done locally inside, let's say inside your own device, let's say smartphone or anywhere, or how?
Sir, can you repeat the question?
My question is, does this model created to be done mandatory to be done in online platform, or it can be done locally as well in your own devices? Is in the future implementation, would this model be implemented in mobile phone or um, any device?
In the future implementation parts, thing is we can implement this whole setup with locally deploying the LLM into the cloud, and then we can work on the app so that we can deploy this as mobile application as well as on the web page also. Presently, it is functional on the web page, but the future amendments part include the deployment with the app also.
Okay. So basically, the online communication is mandatory for this model, right? Because you need the
Uh,
cloud-based cloud-based
Yeah.
storage. All right.
Yeah, we'll need the cloud-based storage to put the LLM over there, sir, because it will be a huge part to put a LLM for the separate model in a phone or in a web page.
Okay. Okay. Thank you. Thank you so much for the answer, and thank you again. Um, then I will proceed with the next presenter. Uh, Paper ID 242. Title, Automated Pattern Recognition of Traditional Fabric using CNN. Okay, I believe the presenter is here.
Yes.
Okay, so I will play your video next. Okay, thank you.
This next presenter is Amirujan O. Kamid from Sultan Kudarat State University, Philippines. His presentation title is Automated Pattern Recognition of Inaol Traditional Fabrics using Convolutional Neural Networks.
The Philippines hosts over 50 traditional weaving practices across its regions. One of the most locally popular is Inaol, a hand-woven fabric with its 63 variations deeply rooted in the culture of Magindanaon and the Renon peoples of Mindanao. All throughout the past decades, it is surprising that there are no reliable documents out there. No Wikipedia, no publicly available databank, and that led me to meet people and cultural experts, which I discovered that these fabrics are of those once being mass-produced from machines. Yes, without any consent from the artistic weavers who crafted their culture with their hands to make ends meet. There are also further problems I have discovered, such as cultural appropriation, declining interest among younger generations, and fading knowledge in aging weavers, which is, in totality, it risks the future of it all. With those problems, it inspired me to materialize the study since 2023 with its older versions that were part of my undergraduate study in Sultan Kudarat State University. I was even motivated to finish this study because, second-handedly, it is as well to rediscover my roots, where I had no chance to learn out back then when I was younger. What I have thought as an undergraduate student was, how can I able to apply my expertise in my computer science field I have chosen? And with all of the research I've done, an idea has surfaced. What if I can make a computer system that acts as a document and at the same time able to automatically identify these patterns? I have traveled 99 kilometers from my university to Bulalo municipality of Sultan Kudarat to collect and validate the data. Working closely with Sultan Kudarat United in All Weavers Association, we have curated CCTV variations which once participated by the weavers. The variations was integral to feed the data to computer using deep learning approaches, specifically vision modeling, while the fieldwork at that point have succeeded. With deep learning, I have long been fascinated with convolutional neural networks' ability, for it is a powerful tool for automated pattern recognition. And as I go through it, I discovered three lightweight models under CNNs that supports the deployment on mobile devices, which is one of my goals. Number one is the MobileNet version 3. Number two is the Efficient Net Lite. And the third is the MobileVit, each pre-trained on ImageNet. Now, one of the question was, how can I able to identify the most efficient and effective model? That's when I prepared my data. The 751 collected images started with the plan, mainly on training the models. But we firstly make images underwent pre-processing stage where the images were fixed, its perspective, and then cropped to a 1:1 ratio. We need to make the data to have this uniformity before feeding them to the models. Yet, one of the issues was also faced were the small number of images and the class imbalances. For we have thought about the dynamic augmentation during training was the key for it. So then, we proceeded to the initial experiment, which each model that we were pre-trained on the ImageNet, fine-tuned to an custom in-all dataset. We used transfer learning with NVIDIA T4 GPUs with Adam Optimizer for the 20 epochs. It was a stratified five-fold cross-validation approach, which is 70% for the training set, 20% for validation, and the 10% for the testing. During the initial experiment, performance metric proved mobile vet performed well among them, which we have then selected to improve it further with the improved experiment we've created. That to check first, here is the confusion matrices, a summary of the trained or fine-tuned models. Clearly, it proves that mobile vet were the CNN that was cleaner and had less misclassifications. Now, focusing on the improved experiment, the focus were to optimize MobileNet further, which was then the final result, has showcased a remarkable validation accuracy of 89.33% and an F1 score of 81.4%.
So I believe that's the end of the video. Thank you so much for such a creative video. Now I open a Q&A session for others to ask some question to the presenter. Mm. All right. So okay, let me good morning. Let me ask you some question. So I believe that I've seen that you have done three models for CNN, three models approach, and then you select the best one. Does the best one satisfy all condition like from the video, I believe that you enhance the picture so you can have a better quality for the model processing. But what if the picture itself is cannot be enhanced further? So does the other algorithm may have better significance in identify the pattern recognition? That's my question.
Thank you for the question. Can you hear me? Am I
Yes, I
audible?
can hear you well.
Thank you. Actually, I've tried different models, but I've chosen the most one that are very portable that you can carry, you can install into your mobile devices. And regarding with the regarding with detecting or distinguishing different variations, because there's a large volume of variations of in all. There's a I only have about a small data set, which is one of the concerning fact of my research. And I've seen that the mixing of and optioning to the parameters would be one of the most efficient way to maximize its potential. And all of those models were performed to that options. And I guess one of the most performing and as presented was the mobile bit because of the augmentation of different images. One images from not so very high definition would be augmented into different images that is going to be darker and then a lighter one that would in different colors. And yeah, that's all. Thank you.
All right. Thank you. Thank you for answering my question, and thank you so much for the presentation. Okay. To proceed, I would like to move on to the next presenter. Paper ID 87, I believe. The title is An Overview on Pipeline Leakage in Carbon Capture Storage. So, the presenter for paper ID 87 is here in the virtual room.
Yes, I'm
Can
here,
you?
sir. Can you hear my
Uh,
voice?
yeah. I can hear you well. So okay. With that confirmation, I will play your video. In short. Thank you.
Okay, sure. Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good morning. I've been to the chair, committee members, and fellow participants. My name is Sharfana Jihad Binti Raisi from UNICECC Islam Malaysia, and this work is studying collaboration with Petronas Technical Services. Today, I'm honored to present my paper title, An Overview on Pipeline Leakage in Carbon Capture Storage. Carbon capture storage, or CCS, is a vital technology for achieving net zero emissions. Pipelines serve as the backbone for transporting the carbon dioxide as they are efficient and cost effective. However, leakage poses significant threats to the environment, to safety, and to the economy. Therefore, this paper focuses on detection and monitoring strategies for pipeline leakage in CCS. Pipelines are critical for moving captured carbon dioxide from the industrial sources to secure storage sites. But when leaks occur, they can undo capture efforts through unintended emissions, cause ecosystem damage, and create safety hazards such as asphyxiation risks. Most importantly, pipeline reliability is essential for building public trust, which determines whether CCS can scale successfully. We move to the root causes of pipeline leakage. Pipeline leakage arises from both internal and external factors. Internal factors include the corrosion from the impurities like water and hydrogen sulfide, pressure fluctuations, and material defects. Meanwhile, the external factors include poor installations, mechanical damage during constructions, and even the geological shifts or seismic activity. Understanding these causes helps us design effective monitoring and mitigation. We move to the impacts of the leakage. The impacts of leakage are wide-ranging. Environmentally, it contributes to the carbon dioxide emissions, soil acidification, and biodiversity loss. Economically, it leads to the downtime, costly repairs, fines, and liabilities. Socially, it erodes public trust and investor confidence. And ultimately, leakage threatens both the technical success of CCS and its climate benefits. Let's see the conventional detection methods on the CCS pipelines. Where the conventional methods include pressuring monitoring, flow monitoring, visual inspections, and sniffer tubes. These are affordable and relatively simple, but they are suffer from low accuracy, delayed response, and often miss small leaks. For CCS pipelines, this makes them insufficient on their own. Meanwhile, for the advanced detection methods, offers much stronger solutions. Fiber optic sensors detect strain and temperature changes along the pipeline. Next, the acoustic emission system can capture sound patterns created by escaping the carbon dioxide. And lastly, machine learning models can analyze diverse data streams to predict and reconstruct leakage conditions in real time. These methods provide high sensitivity, predictive capability, and real-time monitoring, though they come with higher costs and integration challenges. This is the method comparison between the conventional methods and the advanced methods. Here, we can see that the conventional methods are low cost and simple, but limited in accuracy, response time, and scalability. While the advanced methods are more expensive and complex, but provide real-time accuracy and scalability, making them the perfect choice for CCS pipelines. The key challenges ahead. Despite their advantages, several challenges remain. Conventional methods have limited detection range, while the advanced system involve high costs for deployment and maintenance. There are also difficulties in retrofitting all the pipelines and achieving seamless system integration across different water networks. Therefore, this must be addressed for effective adoption. For the future opportunities, at the same time, there are major opportunities. The integration of AI and IoT enables the predictive maintenance and real-time prevents. New corrosion-resistant alloys can improve the pipeline durability. Then, digital twins provide simulations for proactive monitoring and early warning. And across disciplinary collaboration between engineers, data scientists, and environmental experts will drive innovation. Together, these opportunities can secure the future of CCS pipelines. Therefore, in conclusion, pipeline leakage remains a critical risk for CCS systems. Advanced detection methods such as the fiber optics, acoustic sensors, and machine learning are highly recommended for CCS pipelines. However, the challenges in cost and integration need to be overcome. With innovation in technology and strong collaboration, CCS pipelines can be made safer, more reliable, and more sustainable. This will supporting the global ambition of climate change mitigation, specifically in net zero carbon 2050. With that, thank you very much for all the attention. I will be happy to take any questions.
Okay. Thank you again. Thank you for the video presentation. So now, to proceed, I will open the Q&A session for others. If any interest in this presentation, you may ask in this virtual room. Is there anyone? Right. So I would like to ask some question to the presenter. Do you able to hear my voice?
Yeah, it's clear, sir.
Oh, all right. Okay. Good morning to you. I would like to ask this what is your focus in your research? I believe this is an overview for your research direction, but what is your main focus?
Okay, thank you, Mr. Chairman, for the question. Okay, so this research, this paper today is the earliest stage for my research, where the focus of my research is more on the integrating or applying the numerical data from the papers. You can see the first slide of my presentation, where this is joint venture with petroleum industry. From the data, we will do the AI, the artificial intelligence, and the deep learning, so that we can get the more accurate numbers of the pipeline business. Yes.
Okay. All right. Thank you for the answer and the insight. So thank you again for participate in these virtual sessions. Maybe I will move to the next participant. For paper ID 154, the title is Simden builds Prism for landslide displacement prediction by Ren Shuai. Are you here in this virtual room?
Yeah,
Can
I'm
you?
here. Good morning.
Good morning to
Good
you as
morning.
well, Ren. Right. Okay. So with the confirmation, I will play your video next intro.
Okay, thank you.
Dear distinguished experts, I am Ren Shuai from the GNSS Laboratory of University of Malaysia Pahang Sultan Abdullah Wempasat today. I am honored to present our research entitled Simdam Bilstem for Landslide Displacement Prediction, Exploring Rainfall, Hysteresis, and Effective Rainfall Cycles. Landslides are among the most severe geological disasters worldwide, causing between 5,000 and 10,000 fatalities annually and inflicting substantial damage on both human society and the natural environment. The global economic losses from landslides are estimated to exceed $4 billion United States dollars per year. Therefore, developing effective landslide early warning systems is of critical importance. Landslide displacement is a nonlinear and highly complex process, making it difficult to predict directly using conventional models. To overcome these limitations, this study proposes a Simden complete ensemble empirical mode decomposition with adaptive noise approach to decompose landslide displacement data into trend and periodic components. By introducing adaptive noise, Simden effectively mitigates the mode mixing problem inherent in traditional EMD methods. For the displacement prediction model, we adopt bidirectional, long short-term memory bias, while LSTM is widely recognized for its strength in time series prediction by capturing temporal dependencies through forward propagation. It cannot consider future information. The BiLSTM model addresses this limitation by integrating both forward and backward LSTM layers, enhancing its ability to learn complex temporal dependencies and improving generalization. The overall prediction workflow is as follows. 1. Use Simden to decompose the landslide displacement series into a trend component and periodic components. 2. Predict the trend component using a univariate BiLSTM model. 3. Identify external factors responsible for the periodic component, and employ gray relational analysis GRA to evaluate the correlation between these factors and the periodic displacement. 4. Build a multivariate BiLSTM model to predict the periodic component. 5. Combine the two predictions to obtain the final displacement prediction. Evaluate model performance using RMSE, ME, and R. Data and effective rainfall modeling. The dataset used in this study is publicly available from the National Glacier, Permafrost, and Desert Data Center. The displacement records are monthly, totaling 120 observations, as illustrated in the figure. Previous studies have shown that rainfall significantly influences landslide displacement. However, most models only consider current month rainfall. In reality, due to soil infiltration characteristics, rainfall exhibits a hysteresis effect, where previous month's rainfall may still affect current displacement. To account for this, we incorporate an effective rainfall model to capture cumulative rainfall impacts and use it as a key influencing factor. Using Simdan, the displacement data is decomposed into 5 intrinsic mode functions, IMFs, and a residual. The residual, representing long-term environmental trends, is treated as the trend component. The 5 IMFs, driven by seasonal and short-term influences, are combined and treated as the periodic component to reduce computational complexity. 4. Trend prediction, ABILSTM model with 2 hidden layers, each containing 128 neurons, and a dropout rate of 0.2 is constructed. The performance results are RMS, e igual a 3.81 milímetros. Ma e igual a 3.23 milímetros. R al cuadrado igual a 0.98. This indicates high prediction accuracy due to effective decomposition. We categorize external influencing factors into three groups: rainfall, reservoir, water level, and landslide status. A total of 11 candidate variables are selected. GRA is used to quantify the correlation with the periodic displacement, helping select high-quality input features. GRA results identify P7 effective rainfall with a lag of 6 months as the most relevant variable. Therefore, we select for highly correlated variables P2, P7, R2, and D2 across the three categories, and build a multivariate biolistine model for periodic component prediction. The results are RMS igual a 9.41 milímetros, MA igual a 7.69 milímetros, R al cuadrado igual a 0.97. This confirms a good fit between prediction and actual data. The final predicted displacement is obtained by summing the outputs of the trend and periodic component models. Compared with actual measurements, the results are R al cuadrado igual a 0.98, RMS igual a 10.7 milímetros, MA igual a 8.77 milímetros. To verify the effectiveness of our proposed model, we conduct ablation experiments, comparing it with CEE, MDAN, LSTM, and EMD-Bilster models. As shown in the table, our model demonstrates superior accuracy. This study concludes that the effective rainfall hysteresis cycle in the study area is 6 months. The combination of SIMDAN decomposition and bilastium modeling significantly improves prediction performance. However, several limitations remain. 1. The study is limited to open-source data from the Beishu River landslide site. 2. Regional specific parameters should be incorporated for other study areas. 3. Future work should involve higher frequency datasets to further test and refine the model. That concludes my presentation. Thank you for your attention. Dear distinguished
Okay, thank you for the video presentation. Now, as usual, I open a Q&A session for any others who want to ask some question to the presenter. Is there anyone? Okay, I believe there is no one, so I would like to ask one question to the presenter. Can you hear my voice?
Yeah.
Okay. Good morning to you. So I would like to ask, this implementation that you have done is your novelty is based on your uh, modified machine learning model, right? Have you considered a switching method from multiple machine learning model? Maybe it can give a better prediction value. Have you considered it in future implementation?
Good morning. Thank you for your question. I think this model is good, but later I will try other method like LSTM or some different decomposition method. I will try and change some area to test.
All right. That's a good motivation. Okay, so I thank you. Thank you again for your answer, and thank you for participate in this virtual session. So before I conclude this session, I would like to double confirm the first presenter for paper ID 50. Have you are you in this virtual session? I believe Dr. Agahya Surya. Mm, can you hear my voice or so Francis tak update lah kan? Berarti checking cakap apa? Hmm, yeah. I believe we are already at the end of our virtual session, and I extend my gratitude to all of you. Feedback. Hantar feedback. Dekat dalam chat. Dalam person. Oh, okay. I will let, again, I extend my gratitude to all of you, having an interest to participate in this conference proceeding event. And to conclude our session, I would like to have a uh, 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 feedback. I would like you all to fill in the form feedback form in your apa nama group tu? In your participant InECCE WhatsApp group to give a feedback in our virtual session. And again, I'm thanking all of you in participating in this session. So to conclude our session, I would like to have a photo session maybe. Can we all open our camera? Macam nak
Yes.
dekat print screen. Print screen, yeah. Yeah, ni. Tekan je.
Sorry, Chairman. I'm outside, so my camera cannot don't have camera.
Okay,
Sorry.
okay. It's okay. It's okay then. Alright. Okay, so all have open your camera. Okay. In my timing, in three, one, two, three. Smile. Eh, tak boleh ke? Tak boleh next lah. Klik ni. Okay. Tak boleh ya? Ni. Alright. Okay. Okay, I capture you all perfectly. So again, thank you for your cooperation and thank you for your participation in this virtual session. Thank you so much, everyone. Have a good day. You may leave this room.
Thank you.
Thank you very much.
Thank you so
Alright,
much.
thank
Have a
you.
good day.
Okay, thank you.
Thank you very much.
All right, thank you to you as well.